Hello everyone, my name is Akal. Welcome back to our lab continuation. So we're going to continue with our lab that we started on the last week. Here we are going to configure now the firewall and also ensure that now the zones are reachable. So task 6 here says configuring firewalls to work in hot standby mode. The firewalls functions as the enterprise egress gateway. To improve reliability of the HQ network, two firewalls are deployed in hot standby mode. In normal cases, firewall 1 functions as the active device to forward traffic. If firewall 1 is faulty, the enterprise network traffic is switched to firewall 2 to ensure normal communication between the internal and external networks. Step 1. Configure VRRP group on firewall 1 and firewall 2. For details are provided in the table below. Specify the heartbeat interface as its trunk 0 on firewall 1 and firewall 2 and enable hot standby on the firewalls. Ensure OSPF routes on firewall 1 is preferentially selected. Then lastly, configure a link group so that the active standby switchover of the firewalls can be triggered upon the failure of the uplink or downlink interface, that is gig 1/0/0 or gig 1/0/0 of firewall 1. So from the table here, we have got VRRID, and these are the information. So after that, we are going to configure NAT on the firewall. Then we will be through with our lab, our module number 2. Then our third module will configure WLAN. So straight away, let's get into our firewalls and do what the lab requires. So also on this firewall, let's start it. So first step, what we are going to do is now to configure the VRRP. As the practical said, first of all, what we need to establish is the VRRP. From this, the information you are given here. When you see this IP address of 100.1.1.2 and 100.1.3, it tells you the interface where we are going to configure our VRRP. So from the IP plan here, and you get to firewall, you see that interface is interface gig 1/0/0, and come to firewall 2, interface is also gig 1/1/0. So that is where we are going to configure the VRRP. Then the virtual IP address will be 100.1.1.100. So let's do that. So first of all, enter interface gig 1/0/0. Display this. When you display, you can see the IP address is on that interface. Now let's give it VRRP VRID 1. Then our virtual IP will be 100.1.1.100. Then this one is going to be the active firewall. Then we come to our firewall number 2. Enter interface gig 1/0/0. Display this to see if it has an IP address. Yes, it has. So VRID of 1, virtual IP of 100.1.1.100, and this one is going to be the standby. After that, we see what the next is now to configure. Ensure that specify the heartbeat interface or as its trunk 0 on firewall 1 and firewall 2. Remember, its trunk 0 here has gig 102 and 103. So we are going to enable it. Then enable HRP enable. Then after we enable HRP, we are going to configure its trunk 0. So HRP interface trunk 0 remote IP here will be the IP of that its trunk that is on firewall number 2. That was 192.168.100.2. And we are going to now track the interface in case firewall 1, the uplink and the downlink of firewall 1 goes down. The ETH trunk should be able to notice that. So tell it HRP track interface gigabit 1/0/0 and also track interface gig 1/0/1. Display this. You can see here our HRP has been configured. Then we do the same on firewall number 2. We want to quit. So HRP enable. Then after we enable HRP, we configure HRP interface ETH trunk 0. Remote IP here will be the IP of firewall 1 that is configured on the ETH trunk, that is 192.168.100.1. After that, we are going to track the interfaces. So HRP track interface gig 1/0/0. Also, we are going to track interface gig 101. Display this. You can see the HRP configuration. So after you configure those HRP, one firewall should be standby and the other one should be active. But you can see here, this one is firewall 2 is standby, and also firewall 1 is also standby. The reason why that one is like that is because our ETH trunk here, we've not configured this ETH trunk. Now we need to configure that ETH trunk first. So interface ETH trunk 0. Let's display this. You can see it has only IP addresses, IP address of 192.168.100.1. So we are going to configure the link aggregation on those two firewalls. So mode here will be LSCP static. Then we are going to add those gigabit interfaces. So trunk port gigabit 1/0/2 all the way to 1/0/3. You can see here it has turned to master. Also, we come to firewall 2. So interface ETH trunk 0. Mode here will be LSCP static. Then trunk port gigabit 1/0/2 to 1/0/3. So display ETH trunk 0. When it displays trunk 0, you can see all of the two interfaces have been selected. Then to configure this one as the root, we're going to change the system priority. So quit. So tell it LSCP priority here, we'll give it to 100. So display now ETH trunk 0. And come to firewall 2 and also display ETH trunk 0. You can see how here now the system priority has changed to 0. So here you can see now firewall 2 will act as the backup firewall, that is standby firewall. And when you come to firewall 1 here, you see here M, meaning that it is the master. Now synchronization has been enabled between the two firewalls, so we won't need to configure firewall 2. So all the configurations are for the security policy and the NAT policy will just be configured on the firewall, but now will be synchronized to firewall number. So we will proceed with that. So ensure that OSPF routes are preferentially selected. To ensure that routes are preferentially selected on firewall 1, what we are going to do is now to manipulate the cost, so that now while comparing the cost, we'll find that route towards firewall 1 is selected. So to manipulate that, we are going to enter the firewall 2, the interface that connects to gig 101, and give it a higher cost so that it won't select that interface. So quit interface gig 1/0/1. Tell it OSPF cost here, cost of 100. So meaning that now the lower the cost, the higher the chances of it being selected as the preferred route. So it will select route towards firewall number 1 because it will have a lower cost. Next, configure the link group so that the active and the switchover of the firewall can be triggered upon the uplink and downlink failure. That one is what we have configured. The link group here is the link aggregation that we configure on the two firewalls, and also we have triggered the failure that is tracking the interfaces. So step 1 to step number 4 is complete. We are now going to task number 7, that is configuring NAT on the firewall. Here's the requirement. To ensure that users on the 192.168.102.0/24 network segment can access the internet, configure NAT policy on the firewall. Employees on the enterprise need to frequently access the internet, so port translation needs to be enabled. In addition to the IP addresses of the public network interfaces, the enterprise has applied for 7 IP addresses, that is from 100.1.1.4 to 100.1.1.10 from the ISP as the public IP addresses into which private addresses can be translated. So that one is what we configure. So we come to our firewall. So we are going to start with the security policy. So security policy rule name here, we are going to give it policy number 1. After that, the source zone here will be trust. Destination zone will be ISP. Then action here will be to commit. After that, quit, and we are going to now configure the NAT. Quit again. So we're going to configure the 7 addresses that are to be applied from the ISP. So NAT here, address group here, we can give it name of address group 1. Then because they said here, we need to ensure that it is use port address translation. Employees of the enterprise need to frequently access the internet, so port translation needs to be enabled. So you tell it mode here will be equation. We have what no port, no, then you tell it port address translation. After that, we are going to tell the section that will be translated. So section 0, that is 100.1.1.4 all the way to 100.1.1.10. Those are the 7 addresses that will be translated. So then here we tell it route enable. Then quit. After that, we are going to configure the NAT policy. So NAT policy here, rule name, we'll give it rule name of policy NAT. Policy underscore NAT. After that, now we are going to configure the source address. That is the source address here will be 192.168.102.0, the mask of 24. After we configure the source address, now we are going to configure the action to be source NAT. So action source NAT here, we tell it address group, the address group that we configured, address group number 1. Display this to see the configurations. So these are the configuration that we have set on that our firewall number 1, the NAT. So as the practical just said here, they said here to ensure that users on the network of 192.168.102.0/24 network segment can access the internet, configure source NAT policy on the firewall. That is what we've done. That is exactly what we've done here. The source address was this one. Then they told us to configure the source NAT. Then we bind it with the address group that we configured on our 7 addresses that were to be translated. So like I said, all the configuration on this firewall will need to be activated in real time on firewall number 2. Let's check if that is true. Quit and display view. So as you can see here, the configuration for the NAT policy have been enabled on this firewall, and also the security policy that we configured is also on this other firewall, meaning that the synchronization was successfully established between the two firewalls, meaning all the configuration that we do on this firewall are synchronized on the second firewall. I think we are through with today's configurations. There is nothing left here. Everything has been implemented. So thank you guys for watching the video. Thank you for being part of our community this far. So if you are new to the channel, remember to subscribe and also give me a thumb up as a way to support our video production. So let's meet in our next module that will be configuring the WLAN.